What's up, everybody? This is Titans of CNC, and I'm excited because we're making a difference in this trade. I'm also excited because our YouTube channel, our Facebook, all of it's been growing, right? There's a lot of new users in here, so I just want to inspire you guys. If you have not gone to TITANSofCNC.com, please do so. On the upper left-hand side, you'll actually see our regular academy that'll teach you fundamentals, teach you design, how to program and machine parts. There's a wealth of knowledge right there. On the other side, you'll see Aerospace Academy, and that'll just take you to another planet. When it comes to materials, from stainless, titanium, Inconel, Monel, all of it, how to machine it, how to drill it, how to do it all, check it out. Last week, you guys saw us post a video showing a SolidWorks tutorial and showing how you guys can actually spend $20, download SolidWorks, and go through all of our tutorials on the Academy for free. Anybody can learn on the Academy for free. So this week, let's actually go in and program it, right? So we designed it in SolidWorks, so now let's go into MASTERCAM and actually program it, all right? Down below in the description, you will find a link for SolidWorks and MASTERCAM. And right here in this video, you will see the tutorial for the Titan 6M. And not only that, but I'm excited to announce that Nicole is now taking care of the MASTERCAM education tutorials. So Nicole will actually teach you how to program in MASTERCAM, right? We'll slow everything down. We'll actually go over every single tool path and make sure you understand it. And then I'll come back and take the same tools and show you what's possible. And then we'll do a time study, right? At 4,000 RPMs and this feed rate and all of these tools, it was 9 minutes. But then we came over here, we increased the speeds in the feeds, and we made a perfect part, and it came out to this amount of minutes. And now you understand what these tools can actually do, and it will teach you how to compete. Boom. All right, so without further ado, here is Nicole teaching you how to program the Titan 6M.
Hi everyone, this is Nicole with Titans of CNC Academy, and in this video I'm going to show you how to program the Titan 6M from the Building Block series using MASTERCAM. So the first thing we need to do is import our file. So to do that, I'm going to come up to File, and I'm going to choose Open. Next I'm going to select Computer and choose Browse. And now you can see it's not showing any files, and that's because our file type is set to MASTERCAM files only. So I'm going to go ahead and change that to my file type, which happens to be a step file. And now you can see here my step file is showing up, so I'm going to choose that and click Open. Okay, so you can see that it loaded in our file. So the next thing we need to do is set up our machine. So I'm going to come up to the Machine tab, and I'm going to choose the mill dropdown. And for this tutorial, I'm going to go ahead and set it to default, but this is where you would choose your machine's post file. So now that I've got my machine set up, the next thing I want to do is set up our stock. So I'm going to start out by creating a new level. So I'm going to come to Levels, and you can see here it's showing our current level, which is the body. This is our part. So I'm going to add a new level. I'm just going to call it level 2. We're going to name it stock. And I want to make sure that that level is active. So you can see the little check mark next to it shows that we're currently active on that level. So anything we create will be on this level. Now we can go over to the wireframe tab. And in here, I want to create a box around this part. This is going to be our stock model. So I'm going to choose bounding box. So now it's asking us to select one or more entities, so we're just going to choose our part and click End Selection. And you can see it's previewing the bounding box, but this is not the right size, so we need to go ahead and change that. But I can see here looking at our size box that this is not in the correct orientation. So in order to change the orientation, I'm just going to choose this button here. And that's going to allow us to select a new origin point for this bounding box. So I'm just going to choose one of the outer diameter contours of our part. This will snap it to the center. And now it's in the center, but we need to rotate it into position because our Z is facing the wrong way. So I'm just going to click this handle, and you can see when I move my mouse up, it gives me a negative number. So I'm just going to do negative 90 degrees and I'm going to hit enter. And now that it's in the correct orientation, I'm going to hit enter again, and that finalizes that. Now I don't need to make any other changes to the origin for this bounding block, so I'm going to hit enter again. All right, now we can see from the sizes that it's in the correct orientation. So now looking at our setup sheet, we can see that the length of our part, which runs along X, is supposed to be 2.05. So I'm just going to change this to 2.05. And the width of our stock is going to be 2 inches. And the height of our stock is going to be 1 inch, but I'm going to go ahead and change the origin. I want it going from the top. So I'm not going to be adding any stock to the top of our part because it's just going to be faced off in one operation. So I'm just going to choose from the top here, and I'm going to put 1 inch. All right, now we can kind of look at it and make sure it looks right. So there's no stock on top, it's all on the bottom. We got a little gap on each side. And we got a gap on the front and the back. So that looks perfect. Now that we're done changing the size, I do want to make sure that we have the boxes checked for solids and lines and arcs. And now I can click OK. And there we go. So our bounding box is created and it is on the stock level. So the next thing we need to do is create the stock model. So I'm going to come up to our toolpaths tab and I'm going to choose stock model. So the first thing I'm going to do is name it stock. I'm going to uncheck stock plane. I'm going to choose model and I'm going to hit the selection arrow. Now we're going to be selecting that bounding box that we created, and then I'm going to choose end selection. And that's it. So I'm going to click OK. So next we need to set up our work offset. So in order to do that, we need to create a new plane. A really easy way to do that is just to click this guy here. And now we're creating a new plane. So I'm going to go ahead and just snap it to the corner of our stock. And now you can see it's snapped to the corner, but it is still in the wrong orientation. So we need to do the same thing. I'm going to use this grab handle and I'm just going to click. I'm going to move my mouse up and I'm going to type negative 90 degrees and hit enter. And then I'm going to hit enter again. And now it's in the correct orientation, but we do need to move it in on X and on Y. So we'll start with X. Looking at our setup sheet, we can see that we need to move it in 0.05. So I'm just going to choose this handle here. I'm going to move my mouse over and I'm going to type 0.05 and then I'm going to hit enter. And then I want to go ahead and hit enter again to finalize that. And now I'm going to do the same thing for Y. So looking at our setup sheet, I can see that I need to move that in 0.025. So I'm going to click this handle. And this time it's going to be a negative number, so negative 0.025, and then we'll hit enter, and then enter again. All right, that looks good. So we're in 0.025 and 0.05 on X. That looks perfect. So now all we need to do is change the name to G54. So this is going to be the plane that we're going to reference all of our tool paths off of. And now I'll choose OK. So the last thing we need to do before we can begin programming our tool paths is to set up our tools. So I'm just going to come up to the tool manager and I'm going to go ahead and import our building blocks tool library. So I'm going to choose this folder here and I'm going to scroll down and locate my building blocks tool library, and then I'll go ahead and choose open. Now you can see it's populated all of our tools down here, but I'm going to go ahead and add all of the tools that we will need into our part file. So looking at our setup sheet, I can see that the first tool we're going to need is the 3-inch face mill. So I'm going to choose that and then I'm going to hit this arrow up. So now it's in our current part file. Tool number 2 is going to be a 1/4-inch flat end mill. So I'm going to choose that guy and just pop him up there. Tool number 3 is going to be a 3/8 chamfer mill. So I'm going to scroll down, I'm going to find the 3/8 chamfer, and I'm just going to pop that up there. The next tool is going to be a 1/4 inch drill. So I'm going to find that guy. And then we have the 0.1772 drill, and then our 1032 roll tap. So now that I've got all my tools in here and set up, the next thing I need to do is renumber them. So I'm just going to right click each tool. So tool number 2 is the 1/4 inch end mill. So I'm just going to right click and choose edit tool. I'm going to hit next, and I'm going to change that to tool 2. And you can see if I click anywhere, it changes the length and diameter offset to match, and then I can go ahead and click finish. So tool number 3 is going to be the 3/8 chamfer. So I'm just going to right click, edit tool. I'm going to choose next. I'm going to type tool 3 and hit finish. Then we've got the 1/4 inch drill. So I'm just going to right click, edit. I'm going to hit next. And that's tool 4. And the next one is going to be the 177 drill. So I'm going to right click, edit. Next, that's tool 5. And last but not least, our tap, which is tool 6. Okay, so now all of our tools are set up and ready to go. So I'm going to click OK. And now we can begin setting up our tool paths. So the first tool path we're going to be doing is the top face of our part. So we're going to be establishing that first datum. It's that top surface that all of the other tool paths heights are going to be based off of. So we're just going to start by using that 3-inch shell mill to clean up this top surface. So I'm going to come up to our 2D menu, and I'm going to choose face. So I want to make sure that my mode is set to solids, and our selection method is set to loop and face. And I'm just going to choose the top face of our stock model that we created. And then I'm going to click OK. So in our tool tab, I'm going to choose the 3-inch face mill. We're going to be running this at 25 inches per minute. I'm going to do a plunge rate of 100. We're going to be plunging off the part, so I don't need to worry about going super slow or anything, so that'll be good. And then we're going to do a spindle speed of 4,000 RPM. Next, I want to make sure that our rapid retract is checked. This allows the tool to quickly retract away when it's out of the cut. So next, I'm just going to tap through. We don't need to mess with the holder. If you were worried about clearance, like you had fixtures or you were working on like a 5th axis machine, this would definitely be necessary, but we don't need it for this. For our cut parameters, I want to change our style to 1 pass. Since this is a 3-inch shell mill and the part is 2 inches wide, it should be able to do it in a single pass. I want to make sure that our stock to leave is set to 0. This is going to be a finishing pass. So it's just going to clean up the top in one single shot. So our long overlap, 110%, that's perfect. So that'll make sure that the tool is completely off the part when it starts and completely off the part when it lifts up. Our approach distance, I'm just going to set that and our exit to 0 since we have our long overlap set so big. We don't really need those. So that's good. We're not going to be doing depth cuts. Again, it's 20 thousandths of material. We're just going to do it in one shot. In our linking parameters, I want to make sure that I set everything to absolute. And so the reason for this is absolute is always going to be based off of that top origin work offset that we created. So it's going to be based off of this top surface. It's a lot less confusing because any height that you have programmed in there is going to be based off of this top surface. So if it's a negative number, we know it's below this top surface. And if it's a positive number, we know it's above this top surface. So that's really important, making sure all of these are on absolute. So for our retract, I want it to be 0.2 above the part. Our feed plane, we can do 0.1. So this is going to be when the machine starts the feed rate. So when it's down closer to the top of the material, it's going to start to slow down, getting ready to start cutting. So the top of the stock is going to be set to 0, so that's correct. And our depth is actually also 0. So the next thing I want to do is double check in our planes tab that our work coordinate system, tool plane, and construction plane are all set to G54. That's that plane we created. That's essentially our work offset. So it's very important that these are set correctly to that plane we created. If they are not set to the correct plane, you can choose this button and it'll allow you to set the correct plane. So next in our coolant tab, I want to go ahead and set our flood coolant to on, and then I'll click OK. Perfect, so you can see where it's going to drop down off the part over here. It's going to come across all the way off the part and lift. One shot, looks great. I'm going to go ahead and go to our toolpaths tab over here, and I'm just going to choose backplot. This will allow you to see a preview of the tool coming down. I'm just going to hit play. Perfect. Speed it up a little bit. All right, that looks great. So I'm going to click OK. So the next toolpath we need to do is we need to rough cut all of this material from around our part. So to do that, I'm going to come up to the 3D menu and I'm going to choose OptiRough. So in this column here, we have the machining geometry. So right now there's nothing selected. So I'm just going to choose this select entities. And now it's asking us to choose a solid face, surface, or mesh. But I'm going to go ahead, before I select anything, I'm going to go to our levels tab. And I'm just going to turn on, I want to check body to make it the active level, and then I'm going to turn off the visibility of our stock. So next I'm going to triple click on our part, so this will select the entire thing. So I'm going to click 3 times, just like that, and I'm going to go ahead and hit end selection. So now you can see it's showing 117 entities now. So it's got our entire part selected. So looking over here, you can see our wall stock and our floor stock. So this is essentially going to be the stock to leave. So I'm going to change that to 0.005. Same with our floor. Perfect. So next in our toolpath control tab, so this is where we're going to be setting our containment boundary. So this basically tells the tool how far it's allowed to go outside of the part. So we're going to choose boundary chains. We're going to be using the outer diameter of our part. I'll just go ahead and click OK. So I don't need to really mess with anything else other than I'm going to change our compensate to outside. So allow me to give an offset distance. So basically what this offset distance is doing is it's telling it how far outside of this part the tool is allowed to go. So if I had something nearby that I was worried about the tool hitting, I could really control where the tool is able to go outside of the material. So for our offset distance, I just need it to be something greater than the distance from our part to the edge of our stock at the furthest part. So I'm going to do 1 inch. That should be plenty big enough. You know, when in doubt, you could always do it bigger as long as you're not at risk of hitting anything outside of the material, which in this case we aren't. So I want to make sure that include tool radius is checked. And next in our tool tab, we're going to be using a 1/4 inch end mill for this. So we're going to be running the feed rate at 25 inches per minute. Again, I'm going to do a plunge rate of 100 inches per minute. We're going to be starting outside of the material, so I'm not too worried about that. Our spindle speed is going to be 4,000 RPM, and I want to make sure that our rapid retract is checked. Again, we're not going to be messing with the holder in the stock tab. I do want to check rest material, and I'm going to choose one other operation. So it's going to automatically select the stock model that we created. So basically what this is doing is it's telling the toolpath what material needs to be removed based on the stock model that we created. So it sees that 3D model that we created, so it knows what material needs to be removed in order to create this part. Next, in our cut parameters tab, I'm going to change my step over to 10%. Our step down, we're going to do 0.76. So I want to make sure that it goes below the bottom of our part. That way when we flip our part over and machine the backside, we have a little bit of clearance between that hat that's left over and the part we created. So I want to make sure that we check step up. So this is going to allow it, once it's got that outer profile, it's going to allow it to step up onto this next platform here. The amount doesn't really matter too much in this case, but I'm just going to set it to 0.05. Everything else in here I'm going to leave to default. For transitions, since we don't have any internal pockets, I don't really need to mess with any of this. I can just leave it all to default. And in the steep and shallow tab, I'm going to choose adjust for stock to leave. And I'm going to set our minimum depth will be 0. Our maximum depth is going to be negative 0.76. In our linking parameters, I'm going to set our clearance plane to 0.2. And again, that is set from absolute, so the clearance will be 0.2 above the top surface of our part. So I'm going to set our linear entry and exit to 0. This is that lead-in line before it starts that arc. So I don't really need that. I'm just going to leave it. For our horizontal arc entry, I'm going to set that to 0.15. I want it to be kind of big, you know, I want it to have a nice big radius as it's leading into the material. So that looks good. I'm going to do the same thing for our exit arc, 0.15. Ramp angle 10 is great, so that's basically the angle that it starts ramping into the material. For our vertical arc entry and exit, I'm going to set those also to 0. So that's basically like our vertical lead-in radius, and I don't need that since we're starting off the material. All I really want is just that horizontal radius coming into the cut. So that looks great. So I'm going to do the same thing. I'm going to check to make sure our planes are set to our G54 work offset that we created. And our coolant, we want to set flood to on, and then we'll click OK. All right, so you can see how it's going to drop down here. We've got that big radius coming in, and then it's going to walk around the outside of the part. And then once it finishes the outside of the part, it's actually going to lift and come over here. And we've got that big radius again. It's going to start working around the top of the part, coming in. And you can see it's not cutting out the center area. But that's okay, we're going to do that in a separate tool path. We're actually going to ramp down around that center boss, getting it rough cut out so that we can come in and finish them later. So that looks good. Let's go ahead and choose backplot. I want to watch that. Cool, so you can see how it's roughing the outside of the material. It's coming up to the top. Working in toward the center, that looks good. Perfect. Okay, so now let's go ahead and rough cut out that center boss. So to do that, I'm going to come up to the 2D menu and I'm going to choose contour. So once again, I want my mode set to solids, our selection method set to loop only. So I'm going to unclick face, and I'm just going to select the outer contour of our center boss, and you can see the arrow is facing to the left, which is the direction that I want it to cut. If for whatever reason your arrow is facing the opposite direction, you can just choose reverse and that'll actually swap the direction. So the next thing I want to do is I want to set our start point. So I'm going to choose dynamic, and I'm just going to select the center of the corner radius on this boss. That way it's going to kind of start and stop at this point here. So I'm going to click OK, And in the tool tab, we're going to select that 1/4 inch end mill. For this, I'm going to slow it down a little bit since we're ramping into the material. I'm going to do a feed rate of 20 inches per minute. I'll go ahead and set our plunge to 20 as well. It shouldn't be plunging straight into the material since it's going to start above and then it's going to start ramping down, but we'll go ahead and just leave it at 20. We're going to set our spindle speed to 4,000 RPM, and we can go ahead and choose rapid retract. So again, we're not going to mess with the holder in our cut parameters. So for our stock to leave on walls, I'm going to set that to 0.0125. So the reason for this is if we look at our print, we can see that the distance between the bosses is 0.275. So when we subtract the 1/4 inch end mill from that, which is 0.25, we get 0.025 left over. And if we divide that in half, we get 0.0125. So that's going to leave that much of a gap on both sides of the tool to finish it in a later path. Essentially what we're doing is we're centering the tool between the two bosses for this rough cut. So I don't need to mess with depth cuts. It's going to be just ramping down into it. In our lead in and lead out, I want to go ahead and uncheck enter exit at midpoint. For our entry line, I'm going to set that to profile ramp. We're going to do a ramp angle of 1.5. So that's a nice and shallow, easy ramp into the material. For our exit, I'm going to set our length to 0.01 and our radius also to 0.01. It's just real small lead out. And then we can move to our linking parameters. So in here, I want to make sure everything is set to absolute. For our retract, I'm going to do 0.2. Our feed plane will do 0.1. The top of stock is still 0, and our depth, it's actually already gathered that information based off of the contour we selected, but it is in fact negative 0.25, so that's perfect. So next I'm going to go ahead and check our planes, which is correct, and our coolant. I want to set to on, and then we'll click OK. Alright, so you can see where it's going to start ramping down. It's well above the material. It's going to come down and start cutting as it's walking around. And you can see when it's finished after it's done walking around where it's going to lead out. And then the tool is going to lift up. So that looks good. Let's go ahead and backplot that. Slow it down a little bit. There we go. Click play. That looks really good. So you can see the even gap on either side of the tool, and then it's going to lift up, clearing everything. So that looks great. So I'm going to click OK. So the next thing we need to do is clean up this top face. So to do that, I'm going to come up to the 2D menu, drop down, and I'm going to choose Area Mill. So the reason we're going to be using Area Mill is instead of using like a contour, this toolpath is a little more intelligent. So you can actually use the 3D geometry of the part in order to control this toolpath rather than like in a contour where you're going to be primarily using numbers and parameters to control it. So the first thing we want to do is select our machining regions. So I'm going to choose this arrow here, and I want to make sure that my selection method is set to face. I'm just going to choose this top face here, and then I'll go ahead and click OK. So now that we've selected our machining regions, I'm going to go ahead and show you if we choose preview chains, we can see that it's wanting to machine this entire area here. So since we want it to go around the bosses, we need to actually tell it to avoid those. So I'm going to go to avoidance regions, and we're going to choose the selection. Now I'm going to do the same thing. I'm going to select each boss. So I've selected something that I don't want to select. So if I want to undo that, I can just choose unselect, and it'll unselect the last selection I did. So we'll go ahead and choose that one. and that one. So now that we've got all of those selected, I'm going to go ahead and click OK. And now if we preview our chains, now you can see that those areas are going to be exempt from this toolpath. So I'm going to go ahead and turn that off. So I do want to make sure that I have my machining region strategy set to from outside, and then I'll go ahead and click OK. In our tool tab, I'm going to choose that same 1/4 inch end mill. We're going to be running this at 20 inches per minute. I'm going to do a plunge rate of 20 inches per minute as well. Our spindle speed I'm going to set to 4,000 RPM, and then I want to make sure that rapid retract is checked. So in our cut parameters tab, I'm going to change our percent of diameter step over to 95%. Since this is only taking 5 thousandths of material off the top surface of this part, I'm going to go ahead and do a really big step over. So we'll do 95%. Our stock to leave on walls is going to be set to 0.125. So this will allow us to come back with a later toolpath and finish the walls of the bosses. Our stock to leave on floors is going to be 0 since this is a finishing toolpath. So next we can just go ahead and skip ahead to our linking parameters. Again, I want everything set to absolute. Our retract is going to be 0.2, feed plane 0.1, and our depth is going to be -0.25. So for our HST leads, I'm going to go ahead and set our vertical arc entry to 0. We don't need that. Since we're starting off the material, it can just come straight down and over, so that looks good. For our planes tab, everything's set to G54, and our coolant, we want our flood set to on. And then I'll go ahead and click OK. Awesome, so you can see the toolpath. So it's going to drop down, it's going to take its first cut, it's going to come over, take the second cut, and it's just going to do those in order, and then it's just going to start looping around the outer perimeter of each boss. So that looks really good. I'm super happy with that toolpath. Let's go ahead and backplot it so you can see. So it's just cleaning up that edge there, and then it's going to come in, do the next path in one continuous loop. So that looks really good. And then we're going to do one more toolpath around each boss, just cleaning up the walls and what's remaining there that we left in this toolpath. So that looks good. I'm going to come up to the 2D menu drop down, and I'm going to choose contour. I want to make sure my mode is set to solids and my selection method is set to loop. I'm going to go ahead and turn off face for this. So I'm just going to go around and select each of our bosses. And one thing to note when you're selecting geometry, kind of a cool trick, is depending on which side of the line you choose, it's actually going to determine the start point and the direction. So if I select the left side of this contour, you can see that the arrow is facing to the right. But if I select the right side of the contour, it's facing to the left, which is the direction I want. So that's good. If for whatever reason they're facing the wrong direction, you can just choose the reverse button, or you can reselect them. So for the center one, I'm just going to choose this corner here, just the same as last time. So that looks good. So wherever our arrow starts is going to be our start location. So that's going to be starting on this edge. All of the rest are going to be starting on the outer edge of the boss. So that looks good. I'm going to click OK. And in our tool tab, I'm going to be using that same 1/4 inch end mill. Our feed rate for this, I'm going to set to 20 inches per minute. Our plunge, I'll set to 20 as well. The RPM, I'm going to set to 4,000. And I want to go ahead and make sure rapid retract is checked. In our cut parameters tab, I want to set our compensation type to wear. This will allow us to compensate the tool wear right at the machine controller. So typically anytime you're programming a finishing toolpath where you're going to be finishing a wall, I would recommend having your compensation type set to wear so that you have the ability to fine tune it right at the machine and you're not having to go back and reprogram it after the fact. So that looks good. For our stock to leave on walls, we're going to set that to 0 since we want it to come and finish what we left on the last toolpath. So in our lead in and lead out, you can see that it's remembering a lot of information from the last contour we did, but we're going to be changing all of this. So our line for our entry is going to be set to perpendicular. A lot of machines require a perpendicular line in order to set the comp on the machine. So if you have your comp type set to wear and you're intending on being able to control the wear of the tool right at the controller, you may also need your line type set to perpendicular. So for our length, I'm going to set that to 0.01. Our ramp height, I actually do want to add a ramp height. I'm going to do 0.005, just a little ramp so that it kind of comes in, especially on the center boss where it's going to be coming right into material. I think it would be good to have that little vertical lead in so that it's not just plunging straight down into material. For our radius, I'm going to put that at 0.05. And our sweep angle, I want to do let's do 30. That way it's coming in more at a shallow angle to the toolpath. So I'm going to go ahead and copy these parameters to our exit since I want them all to be the same. One thing I am going to show you is kind of a neat trick where you can do kind of a partial spring pass. So a spring pass would be an additional finish pass. So it's the identical tool path, it just repeats it twice. And the reason for this is as the tool comes across in the cut, you know, because of vibration or deflection or any of those other factors, the material could be not quite perfectly straight. So a spring pass would help prevent that. But what I'm going to do in this case is just kind of a partial spring pass to show you how you can do that. So I'm going to adjust the end of our contour and I'm going to extend it, and we're going to extend it. So we know that the boss is 0.375 long. And since it's starting past the radius, we can subtract 0.01 from that. So I'm going to adjust the end. I'm going to extend it 0.365. So that's 375 minus that radius. And this way it's basically going to be doing a complete spring pass on one wall of the boss. And it'll prevent any tool marks as the tool enters or exits the cut. So next in our linking parameters, again, everything is set to absolute. It's already got my retract to 0.2, my feed plane to 0.1, top is 0, and our depth is negative 0.25. So that's exactly what I want. I'm going to double check our planes and coolant. And since it remembered a lot of parameters from our last contour, it already has the flood turned on. So that looks good. So I'm going to go ahead and click OK. All right. So you can see it's starting at this guy here. And you can see how it's going to be starting on this corner. And then it's going to go around and it's actually going to be finishing on this corner. So it's going to lift off over here. So that looks really good. That works out great for the center one too, where it's going to come down into this corner here. It's going to work around and then it's going to come out on this corner. So that looks super good. Just kind of a neat trick to do a partial spring pass on that first contour. So let's go ahead and backplot it so we can watch the tool come down. Super clean, that looks good. Nice. I'm going to slow it down for this last one here in the center. I just want to watch it, make sure that it's not interfering with anything. So we do have a gap between that boss. That looks good. All right, that looks great. It's always important to double check and make sure that the tool isn't running into any other features on the part. So that looks good. I'm happy with that. Let's click OK. And so now that we've got the top face of our part finished, all around the bosses is finished, the next thing we need to do is finish the outer profile of our part. So to do that, I'm going to come up to the 2D menu and I'm going to choose Contour. So now I'm going to go ahead and select, I want to make sure it's the very outer profile of our part. So I don't want to select like this bottom contour. I want to make sure that it's this outer contour. So that looks good. The arrow is facing the correct direction, which is what we want. So I'm going to go ahead and click OK. Next, in our tool tab, I'm going to choose that same 1/4 inch end mill. I'm going to set our feed rate to 20 inches per minute. Our plunge rate, since we're starting off the part, I'm going to do 100 inches per minute. And our spindle speed, I'm going to set to 4,000 RPM. I also want to make sure that our rapid retract is checked, which it is. So next, in our cut parameters, I want our compensation type set to wear, again, so that we can compensate for the wear of the tool right on the controller at the machine. In our lead in and lead out, I'm going to change the length of our lead in to 0.15, make it a little bit bigger. Our radius is also going to be 0.15, and we'll do a sweep angle of 45 degrees. I'm going to go ahead and just copy this over to our exit. So that's going to be this button here in the center. Rather than having to type it all out, we can just copy it. Makes it a little easier. I'm going to uncheck adjust end of contour since we're not going to be using that for this tool path. We can go ahead and go to our linking parameters. And here everything is set to absolute. For our depth, I want to set that to -0.76. This way it's going all the way down past the bottom of our part. Our planes tab, everything is G54, and our coolant flood is already set to on. So now I'll go ahead and click OK. All right, so you can see where the tool is going to drop down here. It's got that nice big lead-in radius. It's going to walk around the part and then lift. We'll go ahead and backplot that. All right, that looks really good. Perfect. So now that we've got the outer profile finished, the next thing we need to do is start adding some chamfers. So the first thing I'm going to chamfer is the very top of the bosses. So I'm going to come up to our 2D drop down and I'm going to choose Model Chamfer. So I'm going to go ahead and select our chain geometry. And with our mode set to solids and our method set to loop, I just want to make sure that I select the very top contour of our chamfer. And that looks good. So now that I've got all of those selected, I'm going to click OK. In our tool tab, I'm going to choose our 3/8 chamfer mill. I'm going to set our feed rate to 20 inches per minute. Our plunge rate is going to be 100 inches per minute. Again, we're going to be plunging outside of the material, so that should be fine. Our spindle speed is going to be 4,000 RPM, and I do want our rapid retract checked. In our cut parameters, I want to set our compensation type to wear. Again, this is a finishing toolpath, and I want to be able to control the size of that chamfer by using the compensation for the wear of the tool right at the controller. So that looks good. I don't need to mess with anything in here. Our chamfer width is going to be set to 0. The reason for this is because since the chamfer is modeled in and we're using that top edge, we don't need to tell it the width of the chamfer. If this was just a sharp edge, we would type in the width. For our bottom offset, we always want to make sure the tip of the tool is hanging off the edge a little bit. We don't want the tip to be right at the bottom edge of the chamfer because it could potentially leave a little lip. So with it hanging off, we have an offset of 0.05. We know that the chamfer is 0.01, so anything greater than that is fine, but I like 0.05. That's a good offset for a 10 thou chamfer. In our lead in and lead out, I'm going to set our length to 0.02, and our radius, I'm going to do something a little smaller. I'm going to do 0.07. For our sweep angle, I'm going to set that to 45 degrees. Again, this way it's kind of coming in at more of a shallow angle relative to the tool path. So that looks good. I'm going to go ahead and copy that over to our exit. And now we can go ahead and check the planes. They look good. And our coolant, we want to set flood to on. And then we'll click OK. All right, so you can see where it's going to start. It's going to drop down, come around, come back up, and it's going to move to the next. That looks good. Let's go ahead and backplot that. Nice. So you can see with the lead-in that we chose, it's far enough away from the other bosses. Perfect. So now that we've got the top of our bosses chamfered, we're going to go ahead and do this outer chamfer here. So I'm going to click OK. I'm going to go ahead and just copy and paste this. So I'm going to right click, I'm going to choose copy, and then I'm going to right click in space here and I'm going to choose paste. So that's going to paste an identical toolpath to the last one. I'm going to come into the parameters by left clicking it. I'm going to come up to our toolpath type. I'm just going to re-choose our chain geometry. So I'm going to remove selected chains and I'm going to hit the arrow to select the new chains. So once again, I want to make sure that I select the very top edge of our chamfer. So I'll just zoom in here. Very top edge. That looks good. Now you can see that our arrow is facing to the right, which is conventional cutting. So I want this to be cutting toward the left. I want this to be climb cutting. So I'm going to go ahead and choose reverse. And now the arrow is facing to the left, which is what I want. So now I'll go ahead and click OK. The tool is going to be the same. The feed rate is going to be the same. So I'll leave that alone. In our cut parameters, I do need to make sure that we allow enough clearance between our tool and the bosses. So I'm going to change our bottom offset to 0.15. Everything else in here is the same. We're going to leave our compensation type to wear. In our lead in and lead out, we can go ahead and do a bigger lead in radius. So I'm going to do 0.15 and we can set our length also to 0.15. And then I'm going to copy that over to the exit and I'm going to click OK. Now we need to regenerate this toolpath. So to do that, I'm going to come up here and choose regenerate all selected operations. And now you can see where it's going to be coming in at that 45-degree angle. It's got that nice big lead in. It's going to be walking around the part and then it's going to come back off. We've got it offset quite a bit here. That should allow us clearance between our boss and the tool. Let's go ahead and backplot this and I'm just going to step it through so that we can watch. Just going to slow it down here. I'm going to hit play. I want to watch it come around this corner. Yeah, we got plenty of room, so that looks good. You can see that offset there. Perfect. So now I'll go ahead and click OK. So since we've got the tool out, let's go ahead and do the hole chamfers. Before we start on that toolpath, I want to know exactly what the chamfer diameter is on this model. So if I come to the Home tab, I can choose Analyze Entity, and I can just click the diameter of that circle, and it's going to tell me right here the diameter is 0.195. So now that we know what our chamfer diameter is, I'm going to come back to our Toolpaths tab, and in the 2D drop-down menu, I'm going to choose Drill. Now it's asking us to choose what holes we want to drill. So I'm just going to choose each of these top holes in the order that I want them to drill. Because you can see the sort order I have set to selected order. There's all kinds of different orders you can play around with, but I like selected order. So I'm going to go ahead and choose OK. And now in the Tool tab, I'm going to be using that same 3/8 chamfer. I'm going to set our feed rate. I'm going to slow it down a little bit. Let's do 15 inches per minute. And our spindle speed I'm still going to have at 4,000 RPM. In our Cut Parameters tab, I want our cycle type set to drill/counterbore. You can see there's a whole bunch of different options here, but for this one, a simple drill is going to be perfect. It's just going to come straight in and straight out. In our linking parameters, I want to make sure everything is set to absolute. And I'm going to check clearance, and we're going to put that at 0.2. Our retract, we're going to do something smaller. I'm going to do 0.05. This way it's only retracting a small amount out of the hole. I'm going to make sure that my clearance is also set to absolute. Top of stock is going to be 0. And for the depth, I'm going to go ahead and set that to 0. And we'll use the calculator to get the correct depth. So it's asking us for the finished diameter, and we know from earlier when we checked the chamfer diameter that it is 0.195. And then we want to make sure that we have add to depth checked, and then I'm going to click OK. So that's going to give us a depth of -0.097 to get that chamfer diameter that we're after. So in our Planes tab, everything is set to G54, and our coolant is going to be set to on. Now I'll go ahead and click OK. Perfect. And so you can see where it's going to start here. It's going to drop down. Let me just step through this real quick. All right, so you can see that looks perfect. It's going just the right amount. And on to the next. All right, that looks really good. Awesome, so now let's go ahead and do the exact same thing to the lower holes. Again, we're gonna go ahead and get that chamfer diameter. So I'm gonna click OK. I'm gonna come up to the Home tab. I'm gonna choose Analyze Entity. And I'm just gonna click that top diameter there for the chamfer. We can see that our diameter is 0.27. So I'm gonna click OK. And now we can come back up to our Toolpaths tab, and I'm going to choose Drill again. So this time we're going to select each of the lower holes in the order that we want it to drill. Since I've got it set to selected order, I'm going to click OK. Our tool again is going to be that 3/8 chamfer. We're going to do 15 inches per minute, 4,000 RPM. In our cut parameters, since the chamfer diameter for this hole is quite a bit bigger, instead of just doing a simple drill, let's go ahead and do chip break. So I'll show you the difference. So normally you would have like a peck drill where it's going to come in and then retract to that full amount before it takes the next peck. But we're going to use chip break, which is going to come in and then it's only going to retract the same amount it goes in. And then it's going to come back down, retract the same amount, come back down. So it's much quicker and more efficient this way. So our peck can be 0.1, that looks good. Our linking parameters, our clearance is going to be 0.2. Again, everything is absolute, that looks good. Our retract for this, This time I'm going to do a negative number. So we know that this surface is below the top by 0.25. So we're going to do our retract negative 0.2. So this way when it's doing the chip break, it's actually starting that cut down closer to the material. So it's not like way up in the air taking forever to get down to that cut. So our top of stock is still going to be 0, and our depth is going to be based off of this negative 0.25 surface. So this is kind of the starting point, and then we'll use our calculator to get down to the diameter that we need. So we'll go ahead and type in our finished diameter, which is 0.27. And we want to make sure that we have it set to add to depth since we've got that negative 0.25 in there. And I'll go ahead and click OK. And now you can see our depth is going to be negative 0.3845. So that takes into account the negative 0.25 to get to this top surface, plus the distance that it needs to get to that finished diameter. So that looks good. In our planes tab, everything is set to G54, and our coolant tab, flood, is set to on. So I'll go ahead and click OK. And now I just want to show you, I'm going to step through, let's backplot this. I'm just going to step it forward. So now you can see it's down at that 0.2 height, and now it's going to start taking cuts, and that's it. Now it's going to retract and move on to the next one. Super quick. Perfect. So now that we've finished the majority of our part and we've got all of our chamfers on the part, the next thing we need to start doing is drilling the holes. So I'm going to start with these lower holes. So since this last toolpath was already on these lower holes, I'm going to go ahead and copy and paste it since it's already got the geometry selected. So I'm going to right click copy, right click paste. I'm going to open up the parameters. So our geometry is already selected. So I'm going to come into the tool tab, and in here I'm going to be choosing the 1/4 inch drill. And we're going to do a feed rate of 18 inches per minute, and our RPM is going to be set to 4,000. In our cut parameters, we're going to go ahead and also be doing that chip break with the 0.1 pec. And in our linking tab, I'm going to keep everything in here the same except for the depth. We're going to go negative 0.85. And the reason for this is because these holes are through holes and our part is 0.75. So I'm going to make sure that I'm far enough past the part. So I think 100 thou should be fine. So negative 0.85. Planes, coolant, that all looks good. I'm going to go ahead and click OK. And now we need to regenerate that toolpath. So I'm going to choose regenerate all selected operations. And now you can see where it's going below the part there. That looks good. I'm just going to go ahead and step this through so you can see. So this is where it's going to take its first cut. So it's down at that 0.2 level. First cut. And now you can see it's not backing all the way out as it goes. Goes in a little bit, comes out a little bit, goes in a little bit more, and then on to the next. So it's much more efficient than trying to do like a pec drill where it's coming all the way out of the hole each time. So that looks good. So next we need to drill the holes on top of the bosses. So to do that, I'm going to come up to drill. And I'm going to choose each hole in the order I want it to cut. Perfect. I'm going to click OK. In the tool tab, I'm going to choose the 0.1772 drill. For our feed rate, I'm going to set that to 16 inches per minute. The RPM, I'm going to set to 4,000 RPM. For our cut parameters, we're also going to be doing a chip break with a 0.1 pec. In the linking parameters, we're going to leave our clearance to 0.2, but our retract, we want to make that a positive number because now we're at the top of the part. But I'm going to make it something really small. I'm going to do 0.05. This way, where it starts the cut will be really close to the top of the material. So for our depth, now looking at our print, we know that the holes need to be tapped at a minimum of 0.15 for the depth. And since we're going to be tapping past that quite a ways to make sure that we get that full thread at that depth, I'm going to make sure that I go a lot deeper with my drill to give my tap lots of room. So I'm just going to go negative 0.45 for our depth. And then we can double check our planes and our coolant, which looks good. And then we'll click OK. All right, we'll go ahead and step through that. That looks good. And you can see where it's starting is a lot closer to the material rather than where it's actually retracting to move. That looks great. All right, now the last thing we need to do is tap our holes. Now when programming a tapping toolpath, we actually use the same operation. It's going to be a drilling operation. So since my last toolpath has a lot of the geometry selection and parameters already correct for my tapping toolpath, I'm going to go ahead and copy and paste the last one. And I'm going to go ahead and change the parameters of the new toolpath. So we've already got the correct geometry in our toolpath type, so I'm going to leave that alone. In our tool tab, I want to change it to our tap. And our spindle speed, I'm going to set that to 1000 RPM. You could do less or more depending on what your machine requirements are, but this is a good starting point for this size tap. So you can see it automatically changed our feed rate, so we're going to leave the feed rate where it sets it. Now we can go ahead and go to our cut parameters. In here, I want to change our cycle type to tap. And in our linking parameters, the only thing I'm going to change in here is I'm going to make our retract a little bigger. So I'm going to do 0.1 just to give it a little more room above the top of the part. And then our depth we want to change. I'm going to do negative 0.275. So we know that it needs to be a minimum thread depth of 0.15. And since taps will have a tapered lead on the tip of the tap, we want to go past the depth called out on the print. So 0.275 should be good. And we'll double check our planes and our coolant, which all looks great, and then we'll click OK. Now we do need to regenerate this toolpath, so I'm going to choose Regenerate All Selected Operations. And you can see where it's going to be dropping down and tapping each hole. So we'll go ahead and backplot that. All right, that looks really good. So the last thing I want to do is kind of show you a way that you can verify all of your toolpaths together at the same time. So in order to do that, we need to come up to our machine group properties here. I'm going to go ahead and expand this. And you can see where we have our stock setup. I'm just going to click that. And we're going to do the same thing that we did previously to do our stock model. I'm going to choose solid and I'm going to hit the selection arrow. Now it wants us to select a solid. So I need to come back to my levels tab and I'm going to go ahead and turn that stock level back on. And I'll just choose that part and click OK. Now I can turn my stock level back off and now I'll go back to my toolpaths tab. So the stock setup is done. So with my tap operation highlighted, I'm going to hold shift on my keyboard and I'm going to choose the facing operation. This will select all of the operations and you can see all of the toolpaths are showing here. So now in order to simulate them all simultaneously, I can come up to this button here where it says Verify Selected Operations and I'll choose that. It's going to open another window and it's actually going to show me the stock. So for mine, I have my stock checked. my tool checked, and I have my workpiece, which is the actual model of the part, turned off so I can see what the actual results are. So I'm going to go ahead and hit play. Just going to speed this up a little bit. Mainly here I just want to make sure that it's not going to be crashing into the material at any point. So I'm going to be looking for gouge marks and things like that. Perfect. So that turned out great. That looks really good. I don't see anything wrong with this part. You can see all of the chamfers. You can see the clearance between our tap and the drill. All of our holes went all the way through the part like they should have. That looks great. So now we can go ahead and close out of this window. And now it's still showing the model with all of the tool paths on top of it. So now the programming for this part is now complete. I hope you enjoyed this video. Thank you for watching.